Morning. Today we're doing our 6th lecture in section 5, in chapter 5. Okay, we're going to be talking about similar figures today. Now, notice these two triangles. They are similar triangles. Similar triangles have the same shape, which means their angles are exactly the same. Notice I've got the two 70-degree angles and a 40-degree angle. But the side lengths are different. The side lengths actually are in proportion, in ratio. Okay, so what that means is if I take 4 over 2, that should equal 2 over 1. And sure enough, both of these simplify to 2. All right, so we're going to check out this triangle. Side LK corresponds to FE. Okay, let's do some highlighting here. LK corresponds to FE. Oh dear, let's erase those. Let's match up the colors used in the words. So, blue. LK corresponds to FE. Now we'll use red. KM corresponds to EG. And green for LM corresponds to FG. All right, now for them to be proportional, their two sides have to match. So the blue over blue has to equal red over red or green over green. All right, so let's substitute in the measure of each side. Okay, so for the blues, we have, this is going to be triangle 1, this is going to be triangle 2. Triangle 1, 4 over 2. Now for the red, we also have 4 over 2. But for the green, we now have 2 over 1. And sure enough, all of those are in proportion. They all simplify to 2 over 1. Or 2. All right, if we know that two triangles are similar, then we can solve for an unknown side by setting up a proportion. Okay, so in this first example, okay, this side is in proportion to this side because those are both the hypotenuse. And this to that, and that one to that one. All right, now we've set up the proportion. Doesn't matter which is number 1 and which is number 2. 3 is to 9 as x is to 6. So we have 9x equals 18. X equals 2 by dividing both sides by 9, which is the coefficient of the x. All right, now we're going to look at this last one, the bottom one. Given that EFGH is similar to LMNO, what is the measure of LO? So we're looking for the red one. So we need to match up our sides. Okay, we have the measure of EF here and LM. So we're going to use that ratio. And the red side is going to end up matching up with this one. Okay, so what we do is we go blue to blue. Remember I said you want to put your variable on top. That's my variable. I'm going to do, almost messed me up. All right, so x is to 6 as 8 is to 2. So this is going to give me 2x equals 48. If I divide by 2, x equals 24. And I have my value of the missing side length. Okay, drawing similar figures. So when we draw a similar figure, what we're going to do is again do a ratio. Okay, so let's do a 3-to-1 ratio. Okay, so this side here, hang on, maybe the light blue will show up. This side right here, okay, is 1, 2, 3, 4, 5 long. So what I'm going to do is draw 5. 5 times 3 is 15. We don't want it that long. Let's do 2. Sorry, let's do a 2-to-1 because otherwise it's too big. Okay, so 2-to-1. If that was 5, this side has to be 10. There's 5, 7, 8, 9, 10. Okay. Now the bottom side, that's 3 long. So my new one has to be 6 long. 3 times 2. 3, 4, 5, 6. All right, now the diagonal is merely drawn along from end to end. Okay, I didn't draw my angle that well, but I would pull out a ruler. I would. So I'm going to. I have a ruler here in my desk. Sorry, that's too long a ruler. Here's a nice short ruler. See, I've got a little 6-inch ruler, so that's what I'm going to use. All right, just line it up and woo, and I was erasing. Wonderful. Isn't that lovely? Okay, so we're going to do this again. 5, 6. There we go. There we go. All right. All right, now we're going to use this to figure out how tall this tree is. Oh, wonderful. And my face is in the way. So I'm going to turn my face off for a minute so you can see it. But you should still be able to hear me. Okay, so we have a 6.5 tall man. And we're going to claim that these are going to be similar triangles. All right, so what I want is the height of the tree, which corresponds to how tall the man is. So we have that the height of the tree is to how tall our man is. Is that 5'5" or 6'5"? Gosh, I can hardly read it. Okay, I'm going to go with 5'5". 5.5, excuse me, feet. And notice I have the two bottom measurements down here. And I'm going to put those together. Okay, so now the height is the tree, so the tree length there is 24 feet. And the man is 3 feet away. All right, so now we have a proportion that we can solve. We do the cross product. 3h is equal to 24 times 5.5. That's 120 and 12, so 132. I'm guessing 24 times, whoops, not 1, 5.5. 132. And now we're going to divide that by 3. And we get that h is 44 feet. Because all the rest of my measurements were in feet. All right. And we are done with this lesson.